In this video, we will study about the solubility of organic compounds in water. The solubility of organic compounds in water follows a simple guideline, which is like dissolves like, which means that polar solvents dissolve polar molecules and nonpolar solvents dissolve nonpolar molecules. Water is a polar solvent. In water, we have an oxygen attached to two hydrogen bonds, and the oxygen has two lone pair of electrons. So this oxygen is sp3 hybridized with a bond angle of about 104 degrees. Now, oxygen being more electronegative as compared to hydrogen, it pulls the bonding pair of electrons towards itself. And because the water molecule has a bent structure or a V-shaped structure, it is polar because it will have a net dipole moment. So water is a polar molecule. This results in a partial positive charge on hydrogen and partial negative charge on oxygen. So water being a polar solvent, it will dissolve polar molecules. Alcohol is polar because the oxygen is more electronegative compared to hydrogen, and so it has a partial negative charge and hydrogen has a partial positive charge. Aldehydes and ketones also have this polar bond here because oxygen being more electronegative, it has a partial negative charge and the carbon has a partial positive charge. Esters and acids have also polar bonds. So because of this, these functional groups have polarity and they will favor solubility. Coming to amines, nitrogen is more electronegative compared to carbon and hydrogen, and so it carries a partial negative charge and the hydrogen carries a partial positive charge. So these molecules have functional groups that impart polarity in them, or these functional groups are polar and impart polarity to the molecule. So, to determine whether a given organic compound is soluble in water or not, we have to weigh the polarity imparted by these functional groups with those of the hydrocarbons, which are nonpolar. Hydrocarbons have carbon attached to hydrogen, and the difference in electronegativity between carbon and hydrogen is very less. So it's a covalent bond with no polarity. So if the hydrocarbon groups are bulky and if they outweigh the polarity imparted by these functional groups, then the molecule will be nonpolar and will not be soluble in water. On the other hand, if these functional groups outweigh the hydrophobic characteristic of the hydrocarbon, in other words, if the hydrocarbons are small in size and the polar groups outweigh their presence, then the molecule will be polar and it will be miscible with water. Let's see some examples. Let's look at ethanol. Now, ethanol has this OH group, which is polar, and it has this ethyl group, which is nonpolar. The OH group can form hydrogen bonds with water, the hydrogen in water has a partial positive charge, and the oxygen in the alcohol has a partial negative charge. So this can continue, and this enables miscibility with water, so ethanol is soluble. Let's consider an alcohol with a long chain of hydrocarbons, say N-octanol. It has 8 carbons, and so this is the hydrophobic part, this is the hydrophilic part. So this is the polar part, and this is the non-polar part. Now, if N-octanol has to form hydrogen bonds with water, then it would be like this. What happens is, because of the bulky nature of the hydrocarbon part of an octanol, it is unlikely that the OH group meets with the water molecule to form the hydrogen bonds. So this becomes unlikely because of the bulky nature of this hydrophobic group. And that's called as steric hindrance. Steric hindrance is when when a group is physically bulky and it's opposing two molecules from coming to each other with close to each other. So because of that, this hydrogen bonding becomes unlikely, and so N-octanol is not soluble in water. So we see how the presence of a bulky hydrophobic group or a bulky hydrocarbon group outweighs the presence of the polar group. Now, amines also form hydrogen bonds. Let's consider a primary amine. The nitrogen is strongly electronegative compared to hydrogen, so it imparts partial positive charges on the hydrogen, and the hydrogen bond will be formed like this with water. So the amine will be soluble in water because of this hydrogen bonds. However, depending on the nature of this bulky group, the polarity of the molecule can change. If it's very bulky and if it outweighs the polarity of amine groups, then it can make it less soluble. Let's see a secondary amine. A secondary amine is, this will have just one hydrogen available for hydrogen bonding. So we can imagine that it is going to be less soluble compared to the corresponding primary amine because the number of hydrogen bonds per molecule with water is decreased. Again, based on the bulkiness of the polar non-polar hydrocarbons, the extent of solubility can decrease.